time, right? That would mean that I'll be using 2 for loops, multiple operations, right? I can even, I think, use a sliding window to some extent, but that'll make it that'll make the time complexity O of n square, right? For each element I, you're exploring all the options with j, right? Which is not an optimal solution. We can do that. It's very easy. All you do is you just create the same structure I showed you in the two-sum problem, and the only thing you check for is the element as the current element at j is equal to the element at I. If j reaches the end of the array, what just happened?
सर कंटिन्यू करें.
Okay, so we are live.
Yes.
Okay, nice. So the brute force approach would be to use a nested for loop. Okay, we can, for each I, we can check all the j's, and we can continue doing that until our I arrives at the second last element, and j is of course arrives at the last index. But the complexity would increase to O of n square. Okay, but we want to avoid this solution. So a smarter way to do this, I mean, still we'll be using O of n square. The complexity would still be O of n square. But another way to not check at every step whether I is equal to j, we can also sort this array so that in case you have 1, 2, 3, 1, you can sort this array. If you sort this as in ascending order, you have 1, 1, 2, 3. Now all you do is you return the 0 index and the first index. You don't have to compare it every step. You don't have that one constant operation. But anyways, if the sorting itself is taking O of n square and then it performs O of 1 at every iteration, that is already getting ignored. It's not gonna cause a bigger, a significant effect on your complexity. Offense score is already worse enough. It's already bad enough, I would say. So I have a solution that I tried. It worked. Same as it worked for nested for loops. Here I'm only using array sort, and I'm just checking the first two indices. But the sort method itself uses offense score, so fills the entire purpose. Oh,
I think the
yeah.
sort method use n log n time complexity, the built-in function. There
Yeah.
are some not the n
Yeah.
square.
Yes, n square is still the worst case for the sort method. So you can call it O of n log n. That's fine too. Um, it reduces the number of operations you have to do to check at every step. But the worst case for even the sort method is, and you can look this up, is O of n square. So when we're thinking about time complexity, we're considering large amount of data, right? So why would the sort method, the sort function even go to O of n square? Is the fact that as your data increases, that sort method can take more and more time, and the time it takes can increase quadratically, okay, in terms of square. That's where we are avoiding that altogether, even though I have an implementation for it, and we can just quickly take a peek at that solution. So where is my submission? Okay, I need to log in. My bad. I should have done this earlier. Give me a sec. I'm almost logged in. Um, I'll go to my submissions and let me show you. Okay.
My connection dropped, so I haven't heard your response.
Okay.
When I'm saying that the sorting complexity of the built-in functions are n log n, it means that I am stating the um, time complexity in the worst case. I'm not saying it is the best case. So there are some sorting algorithms. For example, bubble sort, selection sort, or the insertion sort, which we implement on our own. It could take a big O and square, but the built-in function that we are using, they take uh, n log n time complexity.
Let's take a look at this. Hmm. Okay, that means, yes, you're right. I read it somewhere. It takes off, and because for rearranging the elements inside that array, um, you're basically swapping elements at each iteration, then you're pushing back the smallest. But in that case, we have the total number of the elements in an array is often, and then the complexity would increase with log of n. So if complexity increases, I guess that won't be a significant change. But somewhere I saw that the worst case scenario for that is um, O of n square.
So I want to clarify on this just for
Mhm.
the sake of interview. The
Sure,
purpose
sure.
is not just uh, uh, to hurt your sentiment. It's just for the in case interviewer asks us this type of question. The Whenever we are talking about the complexity, we are talking about the worst case time complexity. If I'm saying that I am using any kind of function, let's say the sort function that is built in the Java or the in the Python. If I am saying that it is giving us n log n time complexity, it means that whatever the algorithm is inside, everything is going to happen in n log n time complexity. The sorting could be efficient, but it is the worst case. If worst case hit, the maximum number of times the code that going to execute is n log n. The You are talking about the big O of n square time complexity. You are right, where we sometimes we write our own algorithms, and those let me just name those algorithms so that in the future everyone can know. If we use the bubble sort, selection sort, or the insertion sort algorithm, that can take uh, big O of n square, I mean quadratic time complexity. And if we do merge sort or the quick sort algorithms, then the time complexity would be n log of n. So it really depends. Whenever we are using any kind of in a language, whenever we are using any kind of built-in method, we must see what is the logic behind and what is the complexity of that particular function. But for now, we can say that um, the good if we try to sort something with the built-in function, even or we write, for example, I write the merge sort on my own, the worst case it would be the n log of n. Only the bubble selection and the insertion sort give us the quadratic time complexity. I hope I have clear things.
Okay, that's very interesting. Thank you. Yeah, I didn't know that. I remember implementing this in Python. I don't know what kind of backend logic does it use. There's a bubble sort, merge sort, or insert. But that was offense, and that's why I was trying to avoid it. I remember that. But yeah, you're right. I am looking this up, and you're absolutely correct. O of n log n is the time. So what does this mean? Could you explain that as well? What does O of n log n means?
It is, if we say, if we see our example one, there is four number of operations. It means that the maximum time if we say that we sort this function, the maximum number of uh, operation that are going to happen are 4 into, and then we are going to take the log of 4. Log of 4, you can calculate it with the help of the value of log 4 with some, online, and just multiply it, and then we will say that whatever would be the for this input in, if for example 1, these in the worst case scenario, these number of times code is going to execute.
That part understood. All I'm trying to understand is what does log of n mean? I know we can compute the value,
Mhm.
but I understood from my previous experience that log means that there's going to be a very gradual change in your time or in the time that your algorithm is going to take.
Mhm.
Log of n means that. So if I'm taking this as the total number of elements that are going to go through this algorithm, then log of n would mean that if you multiply this, then your entire change is a product of a small increment change multiplied by the number of values that you have inside the array. Is that right?
Mhm. Yeah, yeah.
Uh,
Absolutely.
Excuse me, sir.
Sure, sure. Go ahead.
Log 4 multiplied by 4 is equal to 2.4 overall.
Okay.
If we multiply n square, for example, 4 multiplied by 4, so it equal to 16.
Correct.
So in this case, I think n log n is less than n square.
Yes, that's correct. Yes.
अस्सलामुअलैकुम।
वालेकुम सलाम।
सर मैंने थोड़ा सा लेट ज्वाइन किया है, आप इसको थोड़ा सा इसका रिव्यू कर सकते हैं कि ये लॉग हमने यहाँ पे क्यों लिया है?
जी, टाइम हमारे पास चूंकि थोड़ा कम होता है, कोशिश करें कि टाइम पे ज्वाइन करें। यहाँ क्या नाम है इनका, ये नहीं, जैन, राइट?
मैम
Sorry.
Maha Zainab.
No, Faizan, sorry. Faizan, did you get a chance to talk to the management about increasing the time for the session?
नहीं सर, नहीं, वो सर कल कल सर असद भी मौजूद नहीं थे। मैं अभी उनसे डिस्कस करके आपको बता दूंगा इंशाल्लाह कल तक क्या होगा
Okay.
फैसला।
Inshallah. Okay. Anyways, I'll give you a quick review. Thank you, Maz, and thank you so much for clarifying this to me. I didn't know about this. But I think we should also look at when Python does list.sort, what is that doing at the back end? What's the time complexity for Python? Let me quickly check that. Python dot, sorry, list.sort in complexity. Okay, for list.sort, it is okay, that's good. It's n log n. Okay, amazing. Which means it's not that bad. Okay, anyways, so I'll give you a quick review.
Sir, rather we can continue. I'll just go through the recording after the class.
Okay, however you deem fit, no worries. So while we were talking about finding duplicates, so I use this approach. I sort the elements. Now I don't know why did I. Okay, so what I'm doing here is, and correct me if I'm wrong. So I am rearranging these elements. I'm sorting them. So this would lead to, if there are any duplicates, they will fall together because you're sorting them in an ascending order. So if there's a 1, it will come together. If it's 2, it will come together. Sure, it'll come together, right? But can we assume that we'll always get a duplicate in the first and the second index? No, not necessarily. Maybe I have this case where I have 2 as a duplicate, right? So in that case, what I'm doing is I still have to use a loop. Okay. And what I'm doing is I'm going all the way to the end. Not all the way to the end, but I would say the second last index. Okay. And I'm checking at each index whether the next element is similar to the one that my I is at currently. So if this is O of n log n, and if this is O of n, okay.
Why did this log come over here?
So this is the time complexity of this function right here, the sort function, because using certain kind of sorting algorithm, which I can't get into right now because I need to review that how these things work. It's been a while.
Okay.
Yeah,
I'll get it. Uh,
yeah. So what will be the total time complexity of this algorithm? This is just one operation. I'm checking the j for I, for example, or I'm checking the I plus one for I. This is just O of one, okay? Let me clear this up and write this more clearly. So this is O of one, okay? This right here is O of n, and this right here is O of n log n. So since O of n log n is greater than O of n, right? And O of n is greater than, oops, O of 1, O of n, and O of n log n. So if O of n log n is greater than O of n is greater than O of 1, can we say that this is the time complexity for the entire algorithm?
So, whenever we are computing the complexities, for example, for the loop and for the sorting, we are going to add them. If I add big O of n plus big O of n log n, we will see that the answer would be 2n log n. And whenever
Okay.
there is a constant involved, we ignore the constant, then again the equation will be big O of n log n. This is how the complexity of this is going to be calculated.
So you're saying O of n plus
Yes,
O
sir.
of,
I want to clear this,
sure.
ma'am. As you said that O n plus O n log n. So I think we cannot add O n plus O n log n. That don't give us does not give us 2 n log n, because we have
Mhm.
O n is a single variable
Okay.
in the language of mathematics. O n is in another variable, and O n log n is another variable. So it means
Okay.
like ON is like something we treat it as a square or something in the mathematics. Here we have single variable, one is square variable. So I think here we only get the bigger complexity, which is ON log n. So that was wrong. ON plus ON log n gave us 2n log n. So I just
Okay.
want to clarify that.
Okay.
Okay.
It could be the separate entity. Okay.
So the resulting complexity is determined by the dominant term. Okay. So if
Okay.
this is the dominant term, we can discard this. The one that grows fastest.
Sir,
Um,
how can I find the dominant term?
how can you find dominant terms? So if you have multiple terms, which one is more dominant? In order for that, you have to know the order. So O of 1 is the smallest, and then you can go for O of n, and then O of
I think by putting
log.
some value,
About
am
this,
I right? If
Sorry, coming in.
can I add this things the answer of this, how to uh get the maximum order in this situation?
Yeah, if you can do it in 1 minute.
Yeah,
Go ahead.
so here we have ON log n plus ON, but here if we see ON and ON are the same, but with one here is in the multiplication we have log n. So from the common perspective, this means that we are multiplying log n with ON. So log n sorry, ON log n becomes greater than simple O order of n. So I think that's the intuition for getting the maximum complexity.
So was your okay, so this is I think this is how you have to look at it. Uh, I think if you take like a basic example, a very generic kind of non-related to coding, etc. So all you have to see is if you have a container, okay, and then you have a multiple containers inside it, okay. For you to determine how big the object is, you always measure by the outer container in terms of height and the size. You disregard these. Same goes for the time complexities. If your code has operations that are giving you multiple complexities, then you always resort to the one that's going to take the most time. So when you look at your code, you're saying to yourself, which piece of code is going to take the most amount of time, is the worst part of my code that will take the most amount of computational time. That is what you will consider as your time complexity, while others you can disregard. In case of, I think, O of n log n plus O of n log n, what do we have? What kind of complexity will we choose? Will that be O of 2n log n? Can anyone clarify that?
O n log n plus O n log n, that will be 2 n log n.
Will we disregard 2?
Yes, we ignore the constant by
We ignore the
computing the
constant.
complexities.
Cool. So if we have O of n and we have O of n, then we call it O of 2n. And then 2 is constant. So O of kn, this gets disregarded, and again we have O of n.
Yes, you're right.
Perfect. Did
Okay.
I answer your question? Who asked this question? Sorry, I couldn't keep track of it.
Yeah, it's fine. We were just reviewing that.
Hmm. Okay.
Like I was unaware. Like it was a simple sorting question, and we had to do this log n comes up in this, and that was making a question. However, like in the previous question, we use a hash map approach. We can also use a hash map
Yes,
approach
we're going
in
to use
this one
that.
as well,
I'm going
and
to
it
show
will be
you that.
quite fast. As soon as it will just uh,
Mhm. I'm going to show you that next. I have that solution actually. I was trying to go a brute force way and transitioning into it. We are short on time, so I need to hurry. We have another question to discuss. Sorry, I keep interrupting you, Yasser, but once we get more time, we'll have more time to discuss.
sure,
Uh,
sure, no worries.
okay, so let's move this other code. So instead of hash map, I'm using hash set. Hash set, the property of hash set is that it does not allow duplicates, right? So in this algorithm right here, what I'm doing is I'm iterating over the array nums, okay? And I'm checking if the element already exists inside the set, okay? In this case, what I'm saying is, again, you can use the hash map as well, but in hash set, it will not allow duplicates to be added, right? So let's say if you have multiple twos, for our algorithm to realize that it already has an existing number, two, it doesn't have to go. So let me explain to you. 1, 2, 2, 3, 1. Okay. Iterate over the array. Okay. If the number does not exist. Okay. If the number does not exist. If the number exists, return true. Okay. We already have a 2 inside the array or 1 inside the array. So we have a duplicate. If it does not exist, then we're adding that number from that array into this hash set. What's our hash set? Existing numbers. Okay. If it does not exist, if it exists, then we have found our duplicate. Hash set will never allow you to add a duplicate. For example, if it has already added a 2, it will not allow you to add another 2. Okay. But hash maps, it does not have this redundancy control, I think. You can be adding 2, 2, 2 until finally realize that, okay, I already have a duplicate. Also in hash maps, you have to have a key and a value. And if you're doing in terms of key and a value, you have to go based on index or some kind of key you need to know and check if a number already exists there. So that could become complicated. I'm not going to go into why I chose has set for a specific reason, because we're short in time. But yeah, I'm going to base these questions, and please feel free to come up with any questions or corrections as well. Is this clear?
Sir, I think this
Yes,
solution
sure.
will be big of n.
Big open. Yeah, I think that's what I evaluated earlier. But yeah, I'll leave it to you guys. Post in the Slack. Let's move to the next question. Sorry, we don't have much time. Buy Best time to buy and sell stock. Okay, we have a question here. My approach might be a little bit advanced, and we can also, if we can't cover this in this session, we can also continue in the next session and explain it further. The question is, find the best time to buy and sell the stock. Okay. If you're given an array named prices, okay, and if 7, 1, 5, 3, 6, 4, these are the rates on each day, and these right here, if I index them, this would be your day 1, day 2, day 3, day 4, day 5, and day 6. I need to find a day where I can buy the product or the stock for the least price, okay, and sell it for the highest price. So by just looking at this array, you can tell that 1 is the smallest number. So this is the best time to buy. And 6 after that. So the order has to be, you cannot go to yesterday. You cannot go back in time. You have to go forward, right? You need to find the next best day to sell. So after 1, what's the highest number? 5, 3, 6, or 4? 6, of course, right? So this is my best time to sell. So why is the best time to sell? Because if I subtract 1 with 6, it gives me maximum product, which is maximum profit, which is 5. Okay. Um, what if we try another number? How about 3 and 6? Well, 3 is greater than 1, so we are already losing on the best time to buy. So the best time to buy for us would be 1. Any considerations here or any questions?
Sir, why are we not considering 7?
Why are we not considering 7? Um, because 7 is not the best time to buy. If I wait for one more day, I can get it for less. And that we can only find out if we have been given a data, right? We already have a data set. So if I compare 7 with 1, 1 is naturally a better day to buy, right? Unless you have all of zeros here, then this would be your best time to buy and best time to sell. But at the same time, the question is suggesting you need to have a day where you can buy and need to have a day where you can sell. I can consider 7, but then I have 1, I have 5, I have 3. I have so many options to buy, right? So why would I even stay at 7? I can start with 7, right? Because we're dealing with the linear data.
So here is they have stated that we are buying. Let's consider the days: Monday, Tuesday, Wednesday, Thursday, Friday. If I am buying a stock uh, in 7 rupees on Monday, and on Tuesday, if I am getting one stock at 1 rupees, I cannot go to the yesterday and sell something. I have to go to the next coming days to sell something. And I only sell something whenever I have it today, and the days after that I can sell that. I cannot sell anything, you know, without buying, if it is making sense to you. So this is why we are
Ma'am,
not moving backward.
it means we buy a thing in cheap price and sell it in higher price, and we select the day according to the profit.
No, we are buying each day, and whenever something we have bought, we will for the next coming days we will compare our prices. Either I can sell on the Tuesday, either to the Wednesday, either to the Thursday. What is the good day to sell that stock? The
Hmm.
process should move forward. It cannot be backward. We cannot sell something that we have bought on Monday, and if I want, let's say the selling prices were very good on this Sunday, but I was empty at Sunday. I haven't that. So how can I sell that? Are you getting it? That's why we are not considering 7. Although the value of 7 is very high, it was Sunday. I bought a stock in 1 rupees on Monday, and then I can compare rest of the prices. Like on Tuesday, I can sell it in 4 rupees, 4 rupees margin. On the Wednesday, the margin would be 2 rupees. On Thursday, the margin would be 5 rupees. And on Friday, the margin would be 3 rupees, right? If I sell 1 rupees stock, that is why I am selling it on the Thursday with 5% margin.
It means
Did
we can't backtrack in the list.
Yes, we cannot. We
we
cannot sell
cannot?
Okay, okay,
in
I
advance
got it.
if we haven't that.
Reason being, if you see here, I have highlighted this. I was going to come to this actually. I haven't read the problem yet. I'm just directly jumping into the example. But yeah, when it comes to days, can you go back in time? No, not really, right? So you have to find a different day in the future to sell that stock. So you have to look at the details inside the question to see what they're asking
I'm
you.
I'm sorry to interrupt. I guess she's confused that if how can we know about the future values? So it's already given. If I guess if the problem is there, that she's saying
Yeah,
that
you are
how do
right.
we know if we cannot go back in time, then how do we know the future predictive values? So it's already given.
Yeah, that's what I said
Got it.
originally, right?
Yes,
We have a data
got
set.
it.
We have a
I
data set
think we
of
will.
days.
I think we will compare
सर
our.
एक मिनट, एक मिनट, जिनको भी क्वेश्चंस करने हैं अपने हैंड रेस करें, बीच बीच में अपने माइक ऑन करके ना बोलें, डिस्टरबेंस हो रही है। अपने जो क्वेश्चन है अपने हैंड रेस करें और फिर माइक ऑन करके बोलें। जी सर, जुल्फिकार, आपको क्वेश्चन।
Okay, if you allow me, just let me add something here. Actually, the assumption is here that when the price is going down and you have bought the stock there, and you are supposed to sell the stock when the price rises from the bottom. Okay, so it doesn't matter where are you selling, but the right now, for example, at day 2 the price is at 1. Suppose you bought the stock there and price goes up after that, so it is assumed that you must sell that to gain the profit. So the next day, the third day, the price goes up and it is 5, and the guy has sold that stock. So obviously there's a profit, and so we have to calculate that profit, which is 1 minus 5, which is 4. Okay, but here the we have to here it is assumed that the profit should be maximum. So for that we have to wait, and the price still if the price went down at next day, and it is 3, and then on the other day it is 6. So if you bought the stock at the lowest price and sell it at the highest price, what would be the maximum profit? So So we have to observe what would be the maximum. What would be the maximum profit? Okay. So how we calculate that this is the maximum profit? So 6 minus 5, 6 minus 1 is 5. And whereas the predictability is concerned, we can predict stock. There are different phenomena, but right now that is not the part of discussion here. We have to see if the one guy is buying the price at the bottom and sells at the top, what would be the maximum profit? I hope it makes sense.
Yes, Amina, you want to ask something?
Sir, here someone mentioned before, we know the price of stock in future. So why we select 5? We also know the price of stock would be 6. Then we can solve it at that day.
Yeah, you have to sell at maximum price because we have to gain maximum profit. So highest price is 6. So to optimize your profit, we have to sell at 6. So the lowest price is 1 and the highest price is 6 in this whole array. So the maximum profit can be achieved buying at 1 and selling at 6, and which is 6 minus 1, 5. And output is 5 here. Okay?
Yes, sir.
Yeah, I think we have only 10 minutes left, so I'll leave this 10 minutes for questions. We don't want to move forward into the algorithmic implementation unless this is understood. It looks to be straightforward, but it is not actually. We can even continue this tomorrow. But yeah, please, you guys can go ahead and keep asking questions. Make sure you understand this problem at least before the next session tomorrow. Thank you. Also, happy to have you in the session, so Zulfikar, bringing back the memories for system design classes. Thank you.
Yeah, thank you so much. Actually, there are 3 types of question I found in LeetCode about buying and selling the stock. So it depends upon the situation. One question is about regarding the trading in the stock market, and the second one is that shows that how to invest in stock market. So these 3 questions varies according to the situation. So as far as I concern, think that understanding the problem is far important than the code, writing the code of that, because I found that there are typical 4 or 5 types of code, types of code. If you know that, you can write any code there. For example, you have found that we often use loops, for loop and while loop, and then empty arrays like that. So these things are keep on repeating in every code. You have found the pattern there. So the most important thing is you have to understand the situation. Uh, so the experience I gained here in these classes, that the importance that understanding this problem is very, very important. As said earlier, that there are same three same question, almost same headings in the LeetCode. One question is an easy version, the second is an intermediate level, and third is in the hard. So why the same question heading? They are all 3 questions falls in different categories. The reason is the situation of that which we have faced, or the guy has faced in somewhere in that in this case in the stock market. So you have to understand that situation. So try to understand the situation as much as possible so that you know that where we have to apply this code. The rest, I think the coding is not difficult at all. You just that need a little bit more time, and you understand how to implement in programming. So that's why LeetCode DSA is it is language agnostic. So language agnostic mean it does the LeetCode or DSA does not depend upon programming language. It is problem solving skill.
Anyone else has any questions? Yeah, go ahead.
Sir, I think because we cannot predict the future values, so we just compare the current value with the next value. For example, if the in array I buy stock on 7, okay, so the upcoming values are hidden from me. So I will just match the current value with the next value. If it is less, sorry, it is greater, so I can sell the stock. But I cannot predict that how much the next value will be greater. I only check if the next value is greater than my current one, so I can um, plan to sell that stock. Am I right?
Okay, one more thing I want to add here. I think people may be confused here that how we can predict. Let me tell you that we sometimes do simulation. Maybe some of you know that what is simulation. If you simulate the situation, so what we do that? So in that situation, we have to buy at low price and sell at high price. So think it like that. We have simulating the situation. Simulating is simulation mean you are what should I use the word? You are mimicking the situation and in programming language. So you have to tell the program, hey program, buy at low and sell at high, and show me what would be the result or output. So think like that. Don't think that how we have forecasted, how we have predicted the price.
So it means program only comparing it cannot predicting, only comparing the
Yeah,
values.
it's right now it is not prediction. So okay, so think it like that. Though yeah, there are programs, there are guys in the stock market who are expert, they can predict. They have the capability of prediction. But right now, that is very complex situation. You will you will get confused. I think don't don't take a prediction right now here. Think it. We are creating a program we have told the program, hey, Mr. Program, buy on the lowest price and sell on the highest price, and let me know what is the maximum price, maximum profit. This is the situation, right?
Okay, in terms of predictions, we need the prior data. Like for example, in the previous year, this day, what was the stock on that day?
I
Like
think
this one.
I suggest that don't take prediction right now here. Prediction is very complex phenomena. So there are so
Yes,
many
yes.
things.
But in this case, we will only do comparing.
We are yes, we are comparing. So we have
Okay,
to buy what is the maximum profit. Okay.
okay, okay. Thank you.
तो सर कंटिन्यू करें.
Okay, I think we'll have to have another go at it. Tomorrow I'll dedicate only just to this problem because there are many things. The flow that I was going in was to basically make you wonder at different steps. I didn't even read the problem yet. I took you directly into example, so I can show you when you're looking at an example versus what you read here, how do you compare and what is the information you need to extract from the problem, especially a problem that has many details, right? So this will need an entire session. Specifically, I am applying dynamic sliding window to solve this problem. I have the solution, though I'll not share it now. I can show it to you tomorrow. But yeah, the general idea of this is do not think about predictions. Think about evaluating, think about calculating. You have a data set, right? You have been given a data set. You need to work in that data set to predict the maximum, not predict, to calculate the maximum profit you can have if you're going in a direction that is progressive, by which we mean that if you're considering all of these elements as days of the week, Monday, 7 is your Monday, 1 is your Tuesday. So by just looking at it, you can tell that this is not a very good scenario if you just buy at 7 and um, sell it at 1. So if you have other options, which are less than 7, you better disregard this as a buying date. You can buy at 1, you can buy at 5, depending on what your data is. Finally, you need to evaluate the maximum profit you can attain by buying at the best day, by finding the best day to buy, and then after that, find the best day to sell. Okay, a day might seem to be a best day to buy, but it may not be the best day to sell. It may not have a best day to sell after that, right? So we're going to explore some examples tomorrow. At your end, you can give it a try if you haven't solved this already. Read the problem carefully, explore with different examples with a pen and paper, understand these examples, and try to see how far can you get into it. For just playing around and getting an idea, I can give you a wrong answer that I first attempt what I tried, and find the homework for you would be to find a bug in it. Where did I go wrong? Okay. For those who need some sort of assistance in that. So I'm posting that in the chat. Okay.
ओके, जब तक सर चैट में दे रहे हैं तो मैं एक अनाउंसमेंट कर देता हूँ कि अगर हम लीड कोड कर रहे हैं तो लीड कोड सबको करना है, क्योंकि इसमें ये है कि अब लीड कोड सबको करने का मतलब ये है कि सर अपने अपने, मैंने स्लैक पर एज की स्प्रेड शीट जो सर ने ओपन की है वो मैंने स्लैब पे पिन कर दी है और एडिट पर है। अगर किसी को वो, और सब अपने अपने नाम लिखें ताकि अगर जो भी किसी को भी क्वेश्चन करना है या फिर प्रेजेंट करना है तो अपना नाम लिखकर यहाँ पर प्रेजेंट करें, ताकि जब भी आप लोगों की रीड कोड की प्रैक्टिस होगी गूगल के लिए, अगर इस तरह होगी नहीं, क्योंकि अगर सर करवाएंगे आप समझ रहे हैं, फिर समझ लेगा सेक्शन एंड कर देंगे और फिर इसके बाद फिर वो